Morning, sir. My name is K. Charni. My roll number is 2440 and I am from third year AAA section. My topic is Universal Asynchronous Receiver Transmitter Serial Protocol. Here, introduction to UARI serial protocol. UARI means Universal Asynchronous Receiver Transmitter. It is widely used two-way serial communication protocol that transmits data asynchronously without a shared clock between devices. It converts parallel data from a CPU into serial form of transmission and vice versa of repetition using configurable rates, start stop bits, and optional priority bits for error checking. It enables asynchronous data transfer between devices without needing a shared clock signals. Understanding UART is essential for designing efficient communication systems in embedded systems. Here, basic principle of universal asynchronous receiver transmitter. Universal asynchronous receiver transmitter is a two-way hardware protocol for asynchronous serial communication, meaning it operates without a shared clock signal. It transfers data bit by bit between devices, relying on matched birth rate, speed, and data for synchronization. It uses start and stop bit to frame each data packet, ensuring proper synchronization. Data is typically transferred in forms of 8 bits with optional priority bits for error detection. Here, universal asynchronous receiver transmitter hardware components. The core components includes the transmitter and receiver modules within the microcontroller and external chips. A baud rate generates set of communication speed determining bits per second. Additional component including data lines TX and RX, ground and optional flow control signal. Here transmission process of universal asynchronous receiver transmitter. Data is loaded into the UART transmit buffer which then serially transmits bit over the TX line. The receiver detects the short bit, samples incoming bit, and reconstructs the data bytes. Both transmitter and receivers must agree on the baud rate to ensure proper data communication. Here, transmitter and receiver circuit diagram, that means block diagram. Configuring UART in microprocessors and microcontrollers. Configuration involves setting parameters such as baud rate, data bits, priority, and stop bits. Most microcontrollers provide registers or APLS for universal asynchronous receiver transmitter configurations and control. Proper configuration is crucial to avoid data errors and ensure reliable communication. Here some of the applications of universal asynchronous receiver transmitter communication. Universal asynchronous receiver transmitter is used in devices programming, debugging, and serial interfaces. It facilitates communication between microcontroller units and sensors, modules, or computers. Here, universal asynchronous receiver transmitters simplicity makes it suitable to low speed, short distance data exchange in embedded systems. Here some of the advantages and limitations of universal asynchronous receiver transmitter. Advantages includes simplicity, low cost, and minimal wiring requirement. Limitations involves limited communication, distance, and speed, as well as lack of built-in errors corrections. Proper implementation and configuration can mitigate some limitations for effective use. Overall video demonstration over here. A video presentation can visually illustrate universal asynchronous receiver transmitter setup, configuration, and data transmission. Demonstrating real hardware or simulation tools help to understanding practical implementation. The video should highlight key points step such as configure baud rate, sending and receiving data. Here conclusion and key takeaway points. Universal asynchronous receiver transmitter remains a fundamental protocol for serial communication in embedded systems. Proper understanding of hardware setup and configuration ensures reliable data exchange. Combining theory with practical video demonstration enhance learning and application skills. Thank you, sir.